So, good afternoon to all of you. In the last session, we have seen the importance of these combustions. Now, here, uh, if you see, these were the we can say applications of the combustions, such as in power plants, automobiles, chemical industries, domestic appliances. Then we have seen the scope of the combustion for different industries. Then transportation sector, space transportation, power generation, waste disposal, fire, domestic applications. Okay, lightning system. You can see here. In olden days, it was used for the lightning purpose. Okay, now here you can see as that there is a advancement in the technology. We are using this electricity for our lightning purpose. Okay, now if you see. The electricity which we are using it in our house is a product of the combustion process. You might be asking how, but if you see the electricity we get from the power plants, in the power plants, there is a provision of the combustion process. The fuel, coal as a fuel is used, okay, and this fuel is used for the power generation purpose. The fuel is ignited, heat is produced, and from this heat, the turbines are rotated. We get the mechanical energy, which is used for the, we can say, alternators or the generators to produce the electricity. And this electricity, with help of different grids, is transferred in our house, and we are using for our day-to-day applications. So we can see all in the coming years, we are shifting towards the we can say electric vehicles. In electric vehicles, we will not be using the conventional IC engines, rather than we are going to use the uh, battery operated vehicles. Okay, for these battery operated vehicles, we require electricity for the charging purpose, and this electricity is also obtained from these power plants where there is a combustion process. So we can see, I could give a statement that जब तक दुनिया है तब तक ये कंबशन का अपने को एप्लीकेशन है. ठीक है, अभी यहाँ पर देखिए, आप एक फायरवर्क्स का यहाँ पे एग्जांपल लीजिए. यहाँ पे आप देखो अलग अलग कलर्स के फायरवर्क्स आपने को यहाँ पे दिखाई दे रहे हैं. ठीक है ना. सो इसके पीछे साइंस है कि इसमें जो मेटल्स यूज किया है, इसके वजह से अलग अलग कलर्स देता है. ठीक है, और ये आप अगर देखोगे, ये यहाँ पे देखो, इट इज अ कंबशन प्रोसेस. अभी कंबशन प्रोसेस में आपको क्या मालूम होना जरूरी है. पहला होता है अपना थर्मोडायनेमिक्स. ओके, थर्मो इज मींस हीट. इट इज अ ग्रीक वर्ड thermo, which is called as a heat, and the dynamics, which is there with this heat. And combustion also involves this chemical kinetics. Okay, so what is chemical kinetics, we will see. Now, whenever there is a thermodynamics, there is inherent fluid mechanics. Okay, and after that we can see the heat and mass transfer. Okay, which is also important aspects of this combustion. Okay, and if you get a broader picture of that, we can see the applications in the IC engines. Okay, and we can say this is also one type of a vehicle engine used in our automobile in earlier days. Then for the fires, pulse detonation engines, micro combustion. Okay, then the micro combustion means there is a small, we can say very small combustion system. We call it a micro combustion system. Then it is used for the power generation. Then the rocket engines. Okay, then gas turbine engines, furnaces in industrial applications, boilers, incinerators, material synthesis reactions. Okay, recently I'm doing my research in sensors. There is also I am producing certain nanoparticles using flash cyto combustion process. There is also we can see the application of the combustion process. Okay. Now next important is, so for any combustion process we require two important things. One is the fuel and another is the oxidizer. Okay, so what is this fuel? Okay, now fuel, somebody says if I am using petrol in my car, so petrol is your fuel. Okay, yes, it is correct, but there is certain important thing that is a difference between a fuel and an oxidizer. So in our automobiles we are also taking the air. Okay, this there is a air and there is a air filter. From this air filter the air is supplied to the combustion chamber in our IC engines. But if you see, both are required for the combustion process, but there is a fundamental difference between these two things. So what is this fundamental difference? Okay, now the fuel we can define as which donates the electrons during a chemical reaction. Suppose what is a chemical reaction? We call this combustion process as one of the chemical reaction process. And in this chemical reaction process, we can see the fuel which donates the electrons, and the oxidizer in this case is one who accepts the electrons. And this is a fundamental difference between the fuel and oxidizer. And one more important thing which I want to categorize with the oxidizer is nothing but the electronegativity. And this electronegativity is a very important because it tells or it measures the tendency of an atom to attract or bond a pair of electrons. Suppose in oxidizer, if oxidizer is having a very high electronegativity, so then it can be a very good oxidizer. Oxidizer with a very low electronegativity cannot be categorized as a good oxidizer. So this electronegativity word is associated with oxidizer. And this electronegativity word is coined by a scientist whose name is Linus Pauling. Okay, and he is a Nobel laureate. Okay, now here if you see the fundamental definition of electronegativity is the amount of pull that one atom exerts on the electron that is sharing with the other atom. Okay, and here in this table we can see the element and their electronegativity. Here the fluorine F element is having the highest electronegativity of 4. So it is as good as, means it is more electronegative than oxygen. Okay, oxygen is at second position with electronegativity of 3.5. After that there is a, we can say chlorine. Okay, sodium, sorry, not sodium, nitrogen. Okay, then chromium, carbon, sulfur. Okay, hydrogen, phosphorus, then aluminium, manganese. Okay, so manganese, aluminium, these are having very least electronegativity and they can be categorized as the fuels. And the material with the highest electronegativity such as fluorine can be categorized as the oxidizers. Now the fuels and oxidizers can be categorized into gaseous, liquids and solids. Okay, then there is a question that what are the gaseous fuels and oxidizers? Okay, suppose we can take the examples such as CNG, LPG, biogas, producer gas, coke, oven gas, acetylene, methane, hydrogen, butane, propane. These are the, we can say, gaseous fuels. Okay. And we can see the difference between a gaseous fuel and a solid fuel. A gaseous fuel is easily ignited, whereas a solid fuel, such as a wood, it is very difficult to ignite this solid fuel. Okay. Therefore, if you see, if you do a comparison, okay, of a gaseous fuels over the liquid or the solid fuels, these gaseous fuels are having certain advantages, that they are very easy to burn and they are having a higher efficiencies. We can control the emissions. Okay, now we are talking about the emissions. Emissions is a very hot topic now. Automobiles. The automobiles are the source of harmful emissions in our environment. Okay, now government is giving us different stringent norms such as Bharat Stage 6, okay, BS6. Every vehicle should be compliant with the BS6 criteria. Okay, now in order to have a strict emission norms, we have to go for these gaseous fuels. Okay, and the other important thing is that the gas handling systems are very less expensive systems. Okay, so these are, we can say, the advantages of the gaseous fuels or the liquid or the solid fuels. Okay, now next we can see what are the different types of gaseous fuels and oxidizers. Okay, now if you see LPG we are using in our house, okay, for cooking our food. Okay, now in that case, the oxidizer we are using as air. And applications we can see in domestic or in a burner, IC engine system, or in the furnace. Then next is a natural gas. In natural gas, we are using oxidizer as air, and it contains this O2. This natural gas is used in IC engines and in furnaces. Third gas is the producer gas. The producer gas also we are using in the IC engines. Next is methane. Okay. CH4. This is also used in IC engines. Biogas engines or the burners. Acetylene we are using for the gas welding or metal getting applications. Now here we can see what is the typical composition of the gaseous fuels. LPG consists of 70% C8H8 and 30% of C4H10, and it is a combination of these both. Then natural gas consists of 90% CH4 and this C2 and S6 5%. Now another important thing is, if we do comparison of these gases, and if I want to see which gas is going to give me highest calorific value, okay, then we can get this value by seeing the number of H atoms and C atoms. If we see for a particular gas, if the combination of H atom is highest as compared to C atoms, then it is going to have a very high calorific value. Okay, this is a rule you must know. Then next important thing is the characterization of a gaseous fuels. Now just I talk that the amount of heat which is released per unit volume or the mass when it undergoes oxidation at a normal pressure and temperature. Okay, so it's called as a heating value. Now the heating value we can obtain when the heating value of the fuel, when the water is get condensed, we call that the higher heating value. And the lower heating value is the amount of heat released by burning 1 kg of fuel, assuming the latent heat of vaporization in the reaction products is not recovered. Okay, now see here, the higher heating value. Okay, now this lower heating value is devised with help of this higher heating value. Okay, now here if you see, the formula of low heating value is given as the higher heating value minus the mass of H2 divided by mass of fuel multiplied by the change in this, or the delta HV. Okay, and this delta HV is the latent heat of vaporization of water at 298.15 degree Kelvin. Okay, so this higher heating value and lower heating value are very important for the characterization of this gaseous fuel. In the coming lecture, we will see the significance of this. Okay, now how to measure this heating value? Okay, here we can see here, this one is the apparatus, we call it as the Juncker calorimeter. In this Juncker calorimeter, we are supplying the fuel from this line and water from this line. There is a provision of this rotometer in order to determine the flow rate. Okay, and here when this fuel is ignited, the water which is passing, which is gets heated. Okay, and the heated water, the temperature and the exit and the temperature and the inlet, both the temperatures are monitored, and the flow rate is also monitored. And as per the flow rate and as per the rise in the temperature, we are determining what is the heating value of this fuel. Okay. Now, the next important topic is the liquid fuels and the oxidizers. Okay. Now here, liquid fuels, we can see there is a gasoline or the petrol. Then HSD we call as a high-speed diesel, furnace oil, kerosene, alcohols. Then there are different, these are also different types of fuels we require in our process labs. Okay, and these are very sophisticated fuels we are using in this rockets. Okay, uh, now how to measure the calorific value of a fuel? For this, we are using a Bob calorimeter apparatus. Okay, and this Bob calorimeter apparatus, in this liquid is burnt, okay, in presence of oxygen at a pressure of about 2.5 megapascal. And the change in temperature of this water bath, okay, that provides us what is the calorific value of this fuel. Now here you can see here, in this there is a, this one is the water jacket, this is the air jacket, this is a copper calorimeter. Here there is a stirrer for the movement of water, and here we can see this one is the thermometer. Okay, then oxygen which is supplied here. Okay, now here this one is the oxygen valve for the combustion process. These are the electrodes. Okay, now here the there is a provision of this wire, okay, for heating this fuel. Okay, and this, from this battery we are giving the spark. Okay, the fuel is ignited. Okay, the oxygen is supplied from here, and from this we are determining what is the calorific value of the fuel which is burned in this Bob calorimeter. Okay, so till now, we have seen today's session how to categorize the different fuels. Okay, for the combustion process. Okay, now the next important thing is the solid fuels. Okay, now the solid fuels currently for our automobiles. We are not focusing on this solid fuels. Solid fuels, we can see there is a coal or a charcoal. So what is the difference between this? The we can see the coal. It is nothing but obtained from the mines. Okay, and the charcoal we can see wood. Wood we can call it as a coke. When it is burnt in absent of this oxidizer, okay, it gives out this volatile matter, and the remaining part which is remaining, we call it as a charcoal. Okay, Now this we cannot focus this on these coals and the charcoals, whereas we can focus our attentions on these gaseous fuels and the liquid fuels. Okay, now here in today's session we have seen how these calorific values for these liquid fuels and the gaseous fuels are obtained. Okay, in the next session we will going to see we can see the combustion stoichiometry for this. Okay, in the meanwhile I will like to tell you that you must go my previous lectures. You can see the different types of the fuels we have using. Okay, and in this now the fuels we have seen uh, how the fuels are there, but now we are focusing our attention on the combustion process. So we will proceed for the combustion process of the liquid and the gaseous fuels. Okay, so till now, thank you. If you find any doubt, you can contact me. I will share this lecture on our YouTube link. Okay.